Good morning, learners. Good morning, learners. Once again, my name is Mr. Pochilola. Today, I decided to go through an odd examination paper with you, a paper that I randomly selected from my database of papers. So this one is the mock examination, which was written in 2023 by schools in the Central East Education Division. In case you don't know what schools these are schools such as Kasungu Secondary School, Dowa Secondary School, Kamenya Girls, Chipoka Secondary School, Kotakota Secondary School, Malowa Secondary School, Mbomba Secondary School, and Kafukure. These are secondary schools that make up the Central East Education Division. All right, so let's start by looking at the front page. So the front page has a space where you can write your examination number there, over there, and then okay, it says 2023 Malay School Certificate of Education mock examinations, and the subject is physics. Okay, to be written on the paper is meant to be written on which day? On February 24th March in 2023. All right, that's great. More information. So it's paper 1, check that it's paper 1, and also check the subject number. All this just preliminary information about the paper. It shows duration of 2 hours, right? And also check that the paper has 15 printed pages all the time. Make sure you check when you're writing any exam. There is instruction that asks you to check the number of pages, printed pages. If you find that your paper has some pages missing, you have to alert the invigilator and or the supervisor in the exam room that your paper is lacking some pages. All right. And another instruction requiring you to act is filling in your examination number at the top of each page. All right. So there's space where you have to indicate your examination number. Let's say maybe examination number is M for MSCE. So you have M0, maybe your center number is 086, and then this is usually followed by a candidate number. Let's suppose your candidate number is 001. Okay, so fill this in, and you do the same on the rest of the pages. All right, so you do the same on the rest of the pages. Okay, there's more information here about the paper. It is saying that this paper contains 2 sections. Sections A and B, and in section A there are 10 short answer questions, while in section B there are 3 restricted essay questions. Okay, so you are asked to answer all the 13 questions in the spaces provided. So that means you don't need extra answer sheets for this exam. You use the spaces provided. Going down, it's saying that you can use an electronic calculator, okay, preferably a scientific calculator. Yeah, of course, they're saying here that in the table, so there's a table here where you have to indicate the question number that you have answered. You just have to tick. Let's say you have answered question number 1, just put a tick there. Yeah, that's all. So you tick all the questions that you have attempted. There's space that you're not supposed to write anything on the table there. So it says do not write in these columns. So don't write anything there. Okay, so without much ado, let us look at the questions. All right, so number 1 is saying give any 2 ways of communicating experimental results. 2 marks. All right. I'll read the question. It's saying give any 2 ways of communicating experimental results. 2 marks. So this question is worth 2 marks. All right, it's worth 2 marks. That means you have to indicate 2 points. So each point is 1 mark. So what are the different ways of presenting experimental results? This question is taken from probably your Form 3 work, from a topic called the scientific investigations. So over there, you learned about different ways of presenting or communicating experimental results. Okay, so all you have to do is indicate the graphs. Don't write too many things. Graphs, charts, tables. All right, table for results, that is, pictures. You can take a picture of the results and show the results. Diagrams, or just draw a diagram. Yeah. Okay, so here they are just asking you for any 2. Don't write too many or more than what they've asked you for. Here I've just put as many as possible for you to recall that these are the different ways of communicating experimental results. But you have to select any 2. Okay, you have to write down any 2. Why any 2? Because the question is worth only 2 marks there. So don't write more than 2. If you write more than 2, the examiner will simply mark the first 2, and you get your 2 marks there. Okay, so don't write more than what the examiner is asking you for. All right, let's move on to question number 1B. It's saying figure 1, which is this figure here, is a diagram showing part of a vernier caliper. Okay, so vernier caliper is used for measuring short distances or short lengths, such as diameter. For example, diameter of a test tube can be measured using a vernier caliper. Okay, and the other distances. Okay, small distances. Okay, so it's saying what is the value of the reading shown in the vernier caliper above? Show you're working. Okay, so let's see how many marks there are. There are 4 marks. Wow, that means we need to show 4 steps. Okay, the number of marks indicate how many things you need to write down. Okay, so in this case 4 marks means there are 4 steps that you have to show in this box. Okay, that's why I decided to bring this paper now, so that before you sit for your either mock or your MSCE exams, you know the usefulness of marks. Marks indicate how many things you need to present in your answer. If it's 1 mark, it means there is only 1 point that has to be mentioned. If it's 2 marks, it means 2 points are required. If it's 4 marks, it means 4 points are needed for you to put it down on paper. That's very important to note. All right. Okay, so let's go back to the diagram. Okay, when you're taking a reading from a vernier caliper, how do you take a reading from a vernier caliper? Okay, how do you take a reading from a vernier caliper? Remember that a vernier caliper has two scales, namely the main scale. I think they have indicated this is the main scale, so this part here is the main scale, and down here you have the movable scale. A movable scale is also called a vernier scale. Okay, so how do you take a reading from a vernier caliper? Okay, in order to take a reading from a vernier caliper, you go on your vernier scale, the vernier scale on the zero mark, and while you are looking at the zero mark here is this one. Okay, that's the zero mark here. Okay, so this zero mark, you look at the left hand side, the division which is to the left hand side of the zero mark. So on the main scale, so the main scale, the zero mark, to the left of the zero mark, there is this division here on the main scale. Okay, so what is the reading on that division? All right, so you look at the scale, the main scale, and you check the smallest value, what you call the least count. Yeah, how much is the least count, or how much is the value of each division? Okay, so from 0 to 20, there are 10 there are 10 divisions. You can actually count these ones. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, all right. So what is the value of each small division? What is the value of each small division? Okay, by that I mean, what is the value of at that point? Okay, so what you do basically is you simply take 20 divide by 20 divide by what? Divide by 10. Okay, you find that each division is basically 2. So from the first one, second, that's 4, 6, 8, 10. All right, then 12, 14, 16, then 18. So to the left of the 0 mark, one of the vernier scale, there is a value 18 millimeters. There is 18 millimeters. So we are saying the reading on the the reading on the main scale, which is to the left hand side of the 0 mark of the vernier scale, is 18. I'm talking about the reading there. Okay, it's 18. So this is 18. Okay, next you go to the vernier scale and look at the division on the vernier scale, which is exactly coinciding with another division on the main scale. We call this the point of coincidence. So this division there is directly facing this division down here. These divisions are coinciding. Okay, if you look at the others, they are not coinciding with each other, but only these two are coinciding here. They are coinciding. Okay, they are like, you have this one and another one just below. They are coinciding. Okay, so what is the reading on the vernier scale at that point? So let's look at the vernier scale. The vernier scale has 10 divisions from this point here. from this point here to this point there, you have 10 divisions, and you have 10 millimeters or whatever units there are on it. 10. Okay, so that means each division is 1 unit. So where or how many units are there from 0 on the vernier scale to the point of coincidence? So the point of coincidence over here has 3 divisions. You have 1, 2, 3. Okay, so you take that 3, multiply by or add to the value on the main scale. You add that 3 multiplied by what is called the least count. The least count of a vernier caliper in most cases is 0.01. Okay, so you simplify this, it will give you the reading on the vernier caliper there. Okay, so they're saying we should show our working. So let's see what kind of working we need to show. Okay, so we are saying that in order to find the reading on the vernier caliper, use the formula. First of all, the reading is equal to the reading on the vernier caliper is basically the reading on the vernier caliper is simply equal to, I was looking for an equal sign, is equal to what? Is equal to main scale reading. So main scale reading plus main scale reading plus vernier scale reading plus vernier scale reading then you multiply this by the least count. That's the formula. So by writing down the formula, you already have 1 mark there. Don't worry about these abbreviations. They are not universally accepted, but you can still use them. So MSR is vernier scale reading. VSR is, okay, MSR is main scale reading, sorry, I beg your pardon, and the VSR is vernier scale reading, and then LC is the least count, the smallest count, the smallest value on this instrument. So we just mentioned that the main scale reading is 18 millimeters. You can leave the millimeters for the time being. You add this to the vernier scale reading, which is 3, and then you multiply by the least count. The least count of a vernier caliper is 0.01. Again, that step is worth 1 mark. It's worth a mark. Alright, that's worth a mark. Now, when you simplify this, you should be able to, if you multiply 3 by 0.01, you must get 18 add 0.03. You multiply 3 by 0.1, you get 0.03, and then finally you add these. So add this, you get 18. You get 18.03 millimeters. Yeah, so this is how you should have worked out this problem to get all the 4 marks that have been given there. So each step is 1 mark. That's why there are 4 marks there. So pay attention all the time to the number of marks that have been allocated. Okay, always pay attention to the number of marks that have been allocated. Okay, so far so good. Number one, I was asking for 2 ways of communicating experimental results. So once again, you have to write just 2 points. Okay, 2 ways to get 2 marks. Okay, number 2, or number 1B, you are supposed to work out the value or the reading shown on the Venn curriculum. Okay, so remember these steps: the formula, the substitution, and all that is going to give you the required number, which is the required marks, which is 4. Okay. Part C, give one importance of repeating tests during an experiment. Okay, let's suppose you are measuring mass of an object in an experiment. Why is it important to measure the mass several times? Okay, but the question is just asking you for one, not many of them, just one. That means you just need 1 point or 1 importance. Okay, please all the time look at how many marks have been given. The number of marks will indicate or will dictate to you how many points you need to present. Okay, all right, so give 1 importance of repeating tests during an experiment. Why should you do the experiment several times? Or why should you measure quantity several times? Let's say 3 times, 4 times. Why? Okay, so there are different reasons, but they just need one. I'll give you all the reasons that I know, and make sure you just present one when it is needed. So some of the reasons why it is important to repeat tests in an experiment are to reduce errors, but the main reason is just to reduce errors, mainly to reduce what are called random errors. To reduce random errors. Remember that random errors are fluctuations in a measurement, all right, due to maybe personal observations, your inability to position this instrument, the scale, with respect to your eyes. That's parallax error, and other errors. So the repetition of an experiment, followed by, of course, taking average of the measured value, will reduce random errors. That's why we have to repeat an experiment. Random errors, and that's the main reason, but also to ensure accuracy, just to be sure that you're measuring accurately, correctly. Yeah, to ensure accuracy. Accuracy, not accurately, but accuracy. All right. To also, apart from this, you repeating a test or measurement increases precision. I hope you know the difference between accuracy and precision. Alright, remember that accuracy is simply how close a measured value is to a true value, and precision is simply how close the measured values are to one another in a measurement. But also to ensure there are different reasons you can give. and all of them are accepted. Ensure reliability. A reliable test is one which produces the same result all the time, every time the measurement is done. Okay, that's reliable. So any of these is the acceptable answer, but just give only one. Okay, because they're saying give one importance of repeating tests during an experiment. So pay attention to the number of marks which have been shown. All right. I hope so far so good. I'm simply guiding you through. Okay. Yeah. Define number 2A. Define absolute zero. Absolute zero. This is about thermal properties of matter. Okay. Okay. So define absolute zero. What is absolute zero? Okay. Don't confuse absolute zero with absolute temperature. There are these three terms which students get confused with when it comes to thermometers. There is absolute zero, there is absolute temperature, and absolute, there are actually two terms that students get confused with. Absolute zero and absolute temperature. What is the difference between the two? Okay, this is just a by way question. I didn't mean to bring it up. But in case you are not familiar with the difference between absolute zero is just a temperature at which all particles of matter would have zero kinetic energy. All right, that's called absolute zero. It's a temperature, it's a value. Okay, it's a value, it's a temperature reading or value at which all matter are supposedly thought to have no kinetic energy. In other words, they are not in motion. If particles are do not have kinetic energy or have zero kinetic energy, it means they are supposedly thought to be what? Not to be in motion. So it is the lowest possible temperature that matter can achieve. That's called absolute zero. Absolute temperature is the temperature which is based on the Kelvin scale. That's how you define absolute temperature. It's temperature that is measured based on the Kelvin scale. Okay, so I just wanted to highlight these key differences so that you don't end up defining absolute temperature when you are asked to define absolute zero. Okay, yeah. So how do we define absolute zero? So it's saying that absolute zero is the theoretical temperature. Theoretical means it's not achievable, it's just hypothetical. Such a temperature cannot be attained by matter. Okay, it's really, very low temperature. It's hard to achieve. So we are saying it is the theoretical temperature. It's the theoretical temperature. Okay, so absolute zero, I'm sorry for that, it is simply, it is the theoretical temperature. The theoretical is the theoretical temperature at which all particles of matter at which all particles of matter of matter would have zero kinetic energy. That is, if such temperature existed, then particles would have zero kinetic energy or no kinetic energy at all. Zero kinetic energy. Remember that kinetic energy is energy of motion, so particles would not move. So that's the definition of absolute zero. Or you can say, if you want, it's the lowest temperature. It is the lowest temperature the lowest temperature matter can achieve. That matter can achieve. Alright, the coldest temperature. It's the lowest temperature that matter can achieve. In most cases, it's quoted as a minus is quoted as minus minus 273.1 degrees Celsius, or just 0 Kelvin. So this is degrees Celsius. Just write degrees Celsius, or if you want to express it in kelvins, it's 0 Kelvin. That's absolute zero. And so we are saying that such a temperature does not exist. It's just theoretical. It's just theoretical temperature. Yeah. So you can choose one of the two definitions. Don't write both. Okay. After all, it's just 1 mark, so you don't have to write both answers. Okay. Let's move on to the next question. Figure below. It's saying figure below. This should be number 3, I think. Don't know what happened with the numbering. Oh, it's part B. Okay. It's part B of question number 2. All right. So it says figure below shows a diagram of a conical flask fitted with a balloon. All right. So we have a conical flask. Of course, this is not a conical flask. This is a round bottom flask. Okay. Anyway. So it's fitted with a balloon, and as you can see, it's placed in a beaker that has water in it, and okay, there's the thin glass which makes up the conical flask. So the round bottom flask contains air in it. So we have a balloon. Okay. Of course, the diagram is not clear. I think it was just photocopied somewhere from another book. Yeah, so this is a balloon. So that's a balloon. Okay. That's where the balloon is. I just wanted to show you that that's a balloon. Okay. All right. So that's it. So it's being heated. It's being told that it's being heated down here. Yes, the arrow, the blue arrow is indicating that heat is being supplied to the setup here. Yeah, so the question is, what would happen to the balloon after heating? Okay. All right, so remember that initially it contains a little bit of air, but there's more air in the flask. I think. So when heat is applied, it means the air in the flask is also going to get heated. And remember that when when air particles are heated, they gain kinetic energy and move faster. So as they move faster, they collide against each other and against the walls of the container. Okay, so that will increase the force acting on the walls of the balloon. Therefore, the balloon is going to get inflated. Yeah, so you'd say here that the balloon is inflated. Okay. You can say that balloon gets inflated. Yeah. So he's saying what will happen to the balloon. The question is about what happens to the balloon. So the balloon gets inflated. The balloon gets inflated. Or you can say the balloon increases in size. The balloon increases in size. That's what you'd say. The size of the balloon increases. But avoid saying that the balloon is going to expand, or the balloon expands, because that may have a different connotation about the particles in the balloon. We are in this, I'm sure this experiment is simply looking at the effect of heat on the behavior of particles inside the balloon, air particles inside the balloon, which affects the shape of the balloon. Or don't also say the shape of the balloon changes. Of course it does change, but it will undermine the effect of raising the temperature of the gas inside it, the air inside it. Okay, so balloon gets inflated. You know what happens when a balloon is inflated? Its size increases. Okay, so you just have to say one of these two. Don't say too many things. Okay, because it's just one mark there. But where you'll be required to say a lot is here. Explain why, or explain the answer to B2. What is the explanation? Okay, why does the balloon increase in size? Okay, so this has to do with the kinetic theory of matter, especially effect of temperature on behavior of particles. So you need to recall that when heated, when air particles let's go back to what happens to the balloon after heating. So it has to be during heating. We don't want to miss a point there. When the flask is heated, yes, that's better. Because it is the flask that we are heating, and that has an effect on the behavior of the air inside it. So when flask is heated, oh my god, I think When flask is heated, air particles in it gain, you can say air particles in it, we are referring to the air particles in the flask, gain kinetic energy. Air particles in it gain kinetic energy. And the result of that gain in kinetic energy, speed of particles increases. Speed of particles increases. Speed of particles increases. Particles move fast, increases. Is the same as saying particles move fast, increases. So when the speed of particles increases, means particles collide with more frequently. Particles collide more frequently with each other, and with walls of container, walls of balloon, walls of balloon, exerting an outward pressure. On the balloon. Hence, size of balloon increases. Hence, size of balloon increases. Yeah, roughly these are the points that you are supposed to write down. Mind you, it's 4 marks. So you say when a flask is heated, air particles in it gain kinetic energy. You can write kinetic energy in full. It's advisable to write in full. So once particles gain kinetic energy, it means their speed is going to increase also. The particles will have higher speed, will gain more speed due to gain in kinetic energy. And then these particles will collide more frequently with each other and with the walls of the balloon, exerting an outward pressure on the balloon. Hence, size of balloon increases. We notice that the conclusion is agreeing with what we wrote in in part 2. Great. I hope so far so good. Okay. Number 2C, give any one factor that affects magnitude of upthrust. Okay, so remember that upthrust is an upward force which a liquid exerts on an object immersed in it. Okay, or is basically the difference in liquid pressure at the top and at the bottom of an object immersed in a liquid. Okay, so give any one factor that affects magnitude of upthrust. That's the question. Okay. Basically, there are a number of factors that affect the magnitude. The magnitude of upthrust. Okay. I'm sure you're going to recall some of them, or if not all. So, upthrust is affected by a number of factors, namely density of the liquid. Don't just say density, but you have to say density of the liquid. The higher the density of the liquid, the greater will be the upthrust on the object which is immersed in that liquid. But also volume of the object immersed. The volume of the object immersed the volume of the object immersed or submerged. Let's use the word submerged. Submerged. All right. But also depth. The depth of liquid. The depth of the object immersed. Or submerged. So these are the factors, but also acceleration due to gravity. But since all experiments here are done on Earth, so we assume that the acceleration due to gravity is constant, which is 9.81. Okay, so go ahead to look at how each of these factors affect the upthrust, magnitude of upthrust. So the higher the density of the liquid, the greater will be the upthrust. When the volume of the object is submerged in a liquid is higher, it means the amount of liquid displaced is also going to be higher. Therefore, upthrust is going to be higher. Remember that upthrust is just equal to the weight of the liquid displaced by the object. So the bigger the volume of the object, it means the more the liquid will be displaced, and therefore greater will be the upthrust. The extent to which a body goes in the liquid, deep down the liquid, which is the depth, would also affect the upthrust. In fact, the upthrust will be greater. Okay. Lastly, today, we have just started looking at this paper. We're going to continue. This is just part one. We'll come back to the paper to look at the rest of the questions. Okay. Right, so number 3, what does the term resultant vector mean? Resultant vector. What is a resultant vector? Okay. I'm sure you remember what a vector is. A vector is just any quantity that has both magnitude and direction. So a resultant vector, definition of a resultant vector is simply the sum. The resultant vector is the sum as the sum of two or more vectors. When you add two or more vectors, the effect is going to represent the combined effect or magnitude of individual vectors. So two or more vectors added up representing the combined effect. The combined effect or magnitude of the individual vectors. Of the individual vectors. That's called the resultant vector. Just add two forces, for example. The sum of those two forces is going to represent a resultant vector. So we are saying the sum of two a resultant vector is the sum of two or more vectors representing the combined effect or magnitude of the individual vectors. Okay, that's the definition of a resultant vector. Let's stop here for today. When we meet again, probably tomorrow, we're going to look at the rest of the questions from number 3b, or maybe let's just finish off this part. Let's finish off this part. Difference between, it's just 1 mark after all. Differentiate between speed and velocity. All right. Remember, when you were learning this topic under linear motion, you looked at the differences between speed and velocity. You define speed. We can use their definitions. You can use their definitions to show the difference, or you can use their properties to show the difference. Okay. So speed, you can say speed is a vector quantity. Is a scalar quantity. Speed is a scalar quantity. Okay, that's 1 mark. While velocity is a vector quantity. Remember, velocity has both magnitude and direction. Well, velocity is a vector. It's a vector quantity. All right. That's 1 or 2 marks. So each point is 1 mark. By saying speed is a scalar quantity, that's 1 mark. While velocity is a vector quantity, that's 1 mark. Or you can say speed has magnitude only, while velocity has both magnitude and direction. That's the same as saying that speed is a vector quantity. Speed is a scalar quantity, and velocity is a vector quantity. Once again, I would like us to stop here for now. When we meet again, we are going to continue looking at the paper until we answer all the 13 questions. It has been a pleasure looking at the questions together with you, and hopefully we are going to meet again. May God bless you and continue working hard. Wishing you the best in your physics exam. Aim at nothing less than a distinction. Bye.